Hello there, Mr. Sutton here, bringing you the Pre-Cal Honors Chapter 2, Quiz 1 Review Solutions on Solving Polynomials. To solve this polynomial equation, we first look to see if we can take out any common factors, and it looks like we can. These all have an x, so we're going to factor an x out of all this. And if I do that, I'm left with parentheses with a x squared plus x minus 20, all of that equaling 0. And now I can try to factor the stuff that's inside there. So I need factors of negative 20 that add up to that middle coefficient. There's an invisible 1 there. So we have 1 and 20. That's not going to work. Neither does 2 and 10. 4 and 5 could work if I had negative 4 and positive 5. So I'll split that up. I'll have x minus 4 and x plus 5. And now setting each of my three factors equal to 0 and solving, I see for this first factor that x equals 0. And then 4 will zero out that second factor, and then negative 5 the last factor. To solve this polynomial equation, let's first look to see if we can take out common factors. Doesn't look like we can, so we move on to other things. Now, one other thing we check for is to see if it's in quadratic form. We see that we've got fourth power, second power, and a constant. That is quadratic form, where your first exponent is twice the second one, and then you have a constant as the last thing. So we can basically factor this just like a quadratic, only instead of x, we're going to use x squared when we split things up. So I need factors of negative 42 that add up to 1. There's an invisible 1 next to the x squared for that middle coefficient. So we've got 1 and 42, that won't work. 2 and 21 doesn't work. 3 and 14 is no good. Let's see, 6 and 7 would work if I had negative 6 and positive 7. So I'll split this up into x squared minus 6 and x squared plus 7. And now I'm just going to set each of these equal to 0 and solve them individually. So if x squared minus 6 equals 0, then we can say that x squared equals 6. And then square rooting both sides, don't forget the plus or minus, we have x equals plus or minus radical 6. And we can't simplify that anymore. Now for this other one, I can say x squared must equal negative 7 if I subtract 7 there. And then square rooting both sides of that, well, if I'm taking the square root of a negative, I'm popping out an I. So I've got plus or minus I radical 7. For this problem, trying to solve this polynomial, let's first see if we can take out any common factors. Looking at all these four terms, it doesn't look like there are any common factors. But maybe we can factor by grouping since we've got four terms. So let's try that. We'll take an x squared out of those first two terms, and that leaves us with 3x plus 7. For the next two terms, we can take a negative 8 out of both of those, and that leaves us with, let's see, a 3x, positive 3x, and a positive 7 there as well. And now it looks like we have a 3x plus 7 that we can take out of everything, leaving us with x squared minus 8 in the other parentheses. And now let's set each of these equal to 0 and solve. If 3x plus 7 equals 0, well, I could subtract 7 and divide by 3 to get negative 7/3. So that would be one answer. And then for this other one, I can add 8 to the other side. And now I have to square root both sides to solve this. Now when I do that, I'll have a plus or minus. And if I have the square root of 8, I can simplify that. I can split that up into radical 4 times radical 2. So we've got plus or minus radical 4 times radical 2. But we can square root 4, so that's actually plus or minus 2 radical 2. For this problem, to find the remainder by doing this division, and also whether our divisor is a factor of the dividend and the quotient, synthetic division does all of that for us. So to start the process, we write down the coefficients of the dividend, the thing that's being divided. So we have a 1 for the 1x cubed, a 2 for the 2x squared, and then we have a 12 and a 24. And you should always check to make sure there's no missing terms, but there aren't. We go third power, second power, first power, 0 power. Now we're going to write down a little box with the opposite of whatever we have in this parentheses, whatever zeroes out the divisor basically. So that would be negative 1 in this case, because negative 1 plus 1 is 0. And we're going to leave some space for another row and then draw a line. And in this middle row, whatever's in these top two rows here, we're going to add together and put down below. Now, whatever is down below, we're going to multiply by this -1 and put it in the second row. So let's bring down this 1 to start with. It's kind of like adding 1 with 0. And then -1 times 1 gives me another -1 up here in the second row. 2 plus -1 gives me 1 down here. Times -1 gives me -1 again up here. Now I have 12 plus -1, which is 11. And -1 times 11 is -11. 24 plus -11 is 13. This last number right down here in the bottom row, that's your remainder. So we say remainder 13. And if the remainder is 0, then the divisor is a factor of the dividend. If the remainder is not 0, like in this case, then the divisor is not a factor of the dividend. And to write the quotient, we use all the other numbers that are not the remainder, so 1, 1, and 11, and those are the coefficients of the quotient. Now, in terms of the exponents, we always go one exponent lower than we started, and here, you basically divided an x cubed by an x, so you should end up with something that starts with an x squared. So this 1 right here represents 1 x squared in your quotient, and then this 1 is really a plus 1x, and then this 11 is really just plus 11, the constant. To find the remainder from this division and all the other information they want, we will use synthetic division. So let's start by writing the coefficients of our dividend. So we have a 1 for the 1x cubed. And you'll notice we're missing an x squared here. There's really an invisible 0x squared. So when you have those missing terms, you have to have a 0 for a placeholder. Next, we have -18 for the -18x, followed by -8 for the constant. And now for my box number, that's going to be whatever zeroes out my divisor, -4 in this case. Let me leave some space, draw a line, bring down that first coefficient, and now -4 times 1, that's going to be -4 up here in the second row. 0 plus -4 is still -4. -4 times -4 is 16. -18 plus 16 is -2. -4 times -2, +8. And then -8 plus 8 gives us 0. Since our remainder, this last number down here, since that remainder is 0, that means that our divisor, x plus 4, is a factor, so yes, is a factor of our dividend. And then our quotient is these other numbers down here that aren't the remainder. So this 1 really represents 1x squared. It's always 1 lower than the exponent we started with. So that's 1x squared minus 4x. And then this -2 is just the constant -2. On this problem, we are being asked to find the rational roots, possible rational roots anyway, of this polynomial, and then find the actual complex roots of this. So to get the possible rational roots, we have to take factors of the constant divided by factors of the lead coefficient. So we're going to have plus or minus a whole bunch of fractions. So 1 and 2, those are the factors of the constant. Not a whole lot of options there. Factors of the lead coefficient, 6, that's going to be 1, 2, 3, and 6. So we actually have to write out the individual fractions, but this is how we're getting all of the things that we actually write out. So we'll start with just the numbers in the numerator divided by 1. So we've got 1 over 1 and 2 over 1, or just 1 and 2. So nothing fancy there. But now we're going to take all our numerator numbers and divide them by 2. So that gives us 1 over 2 and 2 over 2. But 2 over 2 is just 1, and we already wrote that. So let's move on then. We'll divide all our numerator numbers by 3. That gives us 1/3 and 2/3, neither of which we've seen before. Finally, we'll divide our numerator numbers by 6. So that's 1 over 6 and 2 over 6. But 2 over 6 is the same as 1/3, so we're not going to write that twice. Okay, now I'm going to take these possible rational roots, and to find the complex roots, I'm going to start plugging these in to my polynomial until I come up with a 0 out of doing this. So I'll plug in 1, then -1, then 2, then -2, and I'll just go down the list until I get 0. Let me use my calculator for this, so let me fire that up here. So on my calculator, I'm going to go to my y equals, and I'm going to plug this polynomial here into the y equals. I'll just quickly do that off camera. All right, there we go. I've plugged that into y1. Now I'm going to go ahead and check table set, and I'm going to make sure that independent here is set to ask. What this ends up doing is if you go to table, instead of displaying a bunch of things, it just lets me plug in whatever x values I feel like, and it'll tell me the y value that gives me back. So let me start by plugging 1 into my function here. I'll just enter 1 and press enter, and that gives me 12 back. I want 0 back though, so let me try -1 next. That gives me 6. Next on my list are the 2's, so +2 and -2. Here's +2, gives me 84, not even close. -2 now gives me 0. Great, because then I was going to have to start plugging in fractions, and I wasn't really looking forward to that, although the calculator is doing all the work for me. So anyway, I plugged in 1. It didn't work. I plugged in -1. I plugged in 2. None of that worked, but f of -2 gave us 0. So this is telling me that I can now go ahead and plug in 2 using synthetic division on this polynomial, and that will actually help me break this thing down a little bit more so that I can solve it. So let me set up my coefficients for my polynomial to synthetically divide this. We've got 6, 11, -3, and -2. Let me do my little line and my box number. We've got -2 representing this -2 here. So there's my line. Let me bring down my 6 times -2 gives me -12. Plus 11 is -1 times -2 is 2. Plus -3 is -1 again, times -2 is still 2. Plus the -2, now we get a 0. Good, because if we didn't get a 0, then we did something wrong. So this is telling me that I can factor my polynomial here into x minus my box number, so x minus -2 or x plus 2, you could write that as, and this quotient right here. This is 6x to the second power because we started with third power, and we divided everything basically by x. So this is now 6x squared minus 1x minus 1. All of that equaling 0 now, because I'm trying to find the zeros. So let's see here. X plus 2, I can get an answer out of that pretty quickly. This other one, though, I'm not really sure about. So I could try factoring this, or I could use quadratic formula. It'll probably take about the same amount of time either way. Just to be different, because I usually use quadratic formula, I'm going to try factoring this. I'm feeling brave here because I know that I have numbers in my parentheses that are going to have to multiply to -1, and there's really only one way I can do that. That's if one of the numbers is +1 and the other is -1. So I know I've got some combination of things that multiply to 6x squared, one of them with a -1, one with a +1. I'm going to just go ahead and let me just write this x plus 2 again. Got to bring that down. I'm going to go ahead and just write 2x minus 1 as one of them. And if I've got 2x minus 1, to get 6x squared and -1, I've got to multiply that by 3x and +1. Now, I don't know for sure that this is actually the correct way to factor this. I'm going to go ahead and check, but I just guessed. There's not a whole lot of options here. So we've got 2x times 1 would give us 2x. -1 times 3x would give us -3x. 2x plus -3x gives me this -1x in the middle. So I actually guessed correctly the first time. Go me. All right, at this point, I'm going to go ahead and set each of these parentheses equal to 0 and solve for x. Going from left to right, we've got x equals -2 for that first one. This next one here, I would have to add 1 and divide by 2 to get 1/2. And for this next parentheses, setting that equal to 0, I would subtract 1 and divide by 3. That would give me -1/3. So those are my three answers here.